Our universe is huge. It has billions of galaxies, and each galaxy has billions of stars. But how did it all start? Imagine everything we see, all the stuff in the universe, squeezed into a tiny dot, smaller than an atom. This dot, super hot and packed tight, is where our universe's story begins. This is the world of the Big Bang. The Big Bang theory is the best idea we have about how the universe started. It says that about 13.8 billion years ago, this tiny dot started to grow really fast. It wasn't like a regular explosion, but more like space itself stretching, carrying everything outwards. As the universe grew bigger, it cooled down. This allowed tiny bits like Lego blocks of matter to form. From these tiny bits, stars and galaxies were born, and eventually planets like our Earth. The Big Bang theory helps us understand how the universe changed from the very beginning to today. We have good reasons to believe in the Big Bang. We see galaxies moving away from us, which shows the universe is still growing. We can also see a faint glow left over from the Big Bang, called the cosmic microwave background radiation. This glow is like a baby picture of the universe. These clues and many others make the Big Bang the best explanation we have for how the universe began. In the first blink of an eye after the Big Bang, the universe grew super-duper fast. This fast growth is called inflation. Imagine a balloon with dots on it. As you blow it up, the dots move apart and the balloon's surface gets smoother. Inflation did the same thing to the early universe, making it smooth everywhere. Inflation is a really important idea. It solves some problems that the Big Bang theory couldn't explain. For example, it explains why faraway parts of the universe look so similar, even though they shouldn't have had time to talk to each other. Inflation says these parts were close together before they were quickly pushed apart. One of the strongest clues for the Big Bang and inflation is something called the cosmic microwave background radiation, or CMB. It's like a faint glow left over from the Big Bang. It's a picture of the universe when it was just a baby, only 380,000 years old. The CMB is very smooth, but it has tiny temperature differences. These tiny differences tell us a lot about the early universe, like what it was made of, its shape, and even the tiny seeds that would later grow into galaxies. Most scientists believe in the Big Bang, but there are other ideas too. One idea is called eternal inflation. Imagine a universe that's always bubbling and growing, with our Big Bang just one of many. Eternal inflation says our universe is just one small bubble in a much bigger multiverse. Each bubble universe might have different rules of physics. It's a really big idea that's hard to understand. Another interesting idea is the Big Bounce theory. Imagine a universe that doesn't just start once, but grows and shrinks over and over again like a heart beating. This theory says our universe isn't the first, and it won't be the last. The Big Bounce says the universe expands like the Big Bang, then shrinks, then expands again, and so on forever. These other ideas are interesting, but they don't have as much proof as the Big Bang theory. Section 4, the universe's ingredients, forces, particles, and a mysterious recipe. Everything in the universe follows a few simple rules called fundamental forces. These forces control how tiny bits of matter, called particles, talk to each other. Gravity is the weakest force, but it keeps planets going around stars and shapes the universe. Electromagnetism gives us light, electricity, and magnets. The strong nuclear force holds the centers of atoms together, and the weak nuclear force makes some atoms break apart. Scientists think these forces were all one big force when the universe was very young and hot. Inside atoms, there's a special particle called the Higgs boson. This particle helps give other particles their weight or mass. The Higgs field, which is like an invisible ocean all around us, is connected to the Higgs boson. Particles interact with this field to get their mass. Finding the Higgs boson in 2012 was a big win for science, proving an important idea. But we still have a lot to learn about the Higgs boson and how it works.